We're asked to solve the initial value problem, and we're given h prime of t equals 1 plus 6 sine t, and we're given h of pi over 3 equals negative 3. So what this really is a differential equation. And that essentially means that we're given our item of interest in derivative mode, and then we're asked to essentially back out of it using various integrals, right? Because we want the antiderivative. Now our goal here is to find h of t, and then use this initial condition, this h of pi over 3 equals negative 3, to solve for c. That's essentially what we're doing here. Now this seems like a strange thing to do, but when you go to apply mathematics to pretty much any branch of the sciences, you're working in what's called differential equations, these equations that are given in derivative form, and then you can back out of them to solve for whatever you need to. Even something as simple as F equals ma, right? Newton's second law, which we've all probably at least heard of, is actually a differential equation. This is the second derivative of position. Acceleration here is the second derivative of position. So even this is a differential equation. And as long as you know some initial values, some initial conditions, you can use this equation to solve for position of a projectile, right? Just given the force, which oftentimes is gravity. So it's really a very powerful way of doing things, right? Differential equations are everywhere, right? You have the Schrodinger equation in quantum mechanics. You have all the electricity and magnetism equations if you're studying that branch of physics or engineering. You have the wave equation, the heat equation. Even in economics, you have the Black-Scholes equation, which is a differential equation that's used to model the stock market. So there's a reason why we have a whole class after calculus called differential equations that many majors have to take, because it all comes down to solving these differential equations. So let's solve this one. Okay, well, we're given the derivative 1 plus 6 sine t, so then h of t must be the integral of that, or the antiderivative. So we have the integral of 1 plus 6 sine t dt. We integrate up, so to speak. Well, the integral of 1 is simply t, plus 6, make that minus 6, because the integral of sine is negative cosine. So minus 6 cosine of t plus c. This is a h of t-esque. Well, it's not really h of t because this plus c makes it a whole family of solutions. So let's solve for c here. So we know that h of pi over 3 equals, let's plug in pi over 3 here. So we get pi over 3 minus 6 of cos pi over 3. Well, cos of pi over 3, if you recall, is 1/2. Then we get plus c, and we know this whole thing equals negative 3. How do I know that? Well, because it's given over here. We can use this to solve for c, right? So this gives us pi over 3 minus 3 plus c equals minus 3. Add c to both sides and subtract off pi over 3. We get c equals negative pi over 3. Now, as a final step, we plug in c here for our missing constant to get the actual expression for h of t. So h of t then in its final form is h of t equals t minus 6 cos t minus pi over 3. So really the only difference in practice with an initial value problem is that you're given this initial condition here and you use that to solve for c. So anytime you see initial value, that means you should not have a c in your answer, but rather you should use the given condition to solve for c.